Hi, this is Mr. VanScoyoc. In this video, I'm going to take you through our notes on geologic time. You can see that I'm in the Geologic Time 101 lesson. And let's take a look at our slides. Geologic time, our key concept. Earth's processes seen today, such as erosion, mountain building, and glacier movement, make possible the measurement of geologic time through the methods such as observing rock sequences and using fossil tools to correlate the sequences at various locations. Okay, so there's some big scientific words in this key concept here. Basically what this is saying, what this boils down to, is by looking at how erosion, mountain building, and glaciers kind of behave and change the Earth today, we can see how fast and how similar those processes are and compare them with past with landforms that we see today and kind of deduce or infer what happened at that location in the past. So knowing how erosion affects certain things today, we can look and identify that in the rock clues. Same thing with mountain building and glaciers. We see what the results are today, and we kind of apply those same ideas and processes to other rock formations and things that we see today on the planet. Fossils also help us to correlate. Correlate just means to match up different events from different locations. So looking at different locations and using fossils as a way to kind of match those up. Match up locations that may be many miles apart. Geologic time. Earth is estimated to be about 4.5 or 4.6 billion years old. Number 2, timelines describe the timing and relationship between events in the Earth's history. Number 3, relative dating estimates the order of prehistoric life and geologic events. We're going to talk more about relative dating here shortly. Observing fossils. Number 4, observing fossils in rock layers at different locations is a part of relative dating. So fossils are going to be part of the clues we use for relative dating. The law of superposition. Layers of rock and the things in those layers, such as plants or animals, are almost always younger at the top, and layers of rock and the things in those layers are older at the bottom. This is assuming that they have not been disturbed. Okay? If we find them in their natural state, when you look at a section of rock, if you were to dig down through the soil into the layers of sediment and down into the rocks underneath that, those layers, and more specifically sedimentary rock layers, but may also include some igneous rock layers. But going through those layers as you go down would get older and older and older. Number 3, intrusions. Intrusions are again another way of saying volcanic rock, magma and lava, intrusions or extrusions. When magma and lava are found to kind of burn their way through those layers or burn across those layers, the intrusions are always younger than the rocks that they cut across. Okay? The intrusion could not burn its way across or up through those rock layers if the rock layer wasn't already there. So if it was there before the magma burned its way through, those other rock layers must have been older and the intrusion therefore younger. Relative age. Number 1, compares the ages of one thing to another. Relative age does not tell us the actual age. Let me give you an example. If I told you that I have a brother who was born before me, you could put that in part A. So my brother Jason was born before me. Then I was born. And after me, my sister was born. That doesn't tell you my exact age, but it does tell you that I am younger than my brother Jason. it tells you that I am older than my sister Jody. That is simply the idea of relative age, and I actually use my relatives to kind of help demonstrate that idea. You could come up with your own example. Number 4, geologic time scale. First, only use relative ages. Okay, the geologic time scale is just a timeline that paleontologists use to kind of describe events, important events in Earth's history. Number 5, absolute dating is now possible to get the actual age of rocks or fossils. We have different techniques. I won't go into that in this presentation, but that would be something you could do some research on or look up in your textbook. Absolute dating can actually give us a very good estimate of how old these rock layers are, and therefore the fossils that are in those rock layers.